Okay, so the purpose of this presentation is to be able to define oxidation and reduction, to write half equations identifying the oxidation and reduction processes in redox reactions, and to be able to combine half equations to give an overall redox reaction. I'm going to use this example to illustrate some of the important points about oxidation, reduction, and how to do these overall equations and so on. The first thing to notice here is it's important with all redox equations to check that the atoms balance and that the charges balance. So before we go any further, let's have a look. We've got one manganese here and one manganese on the right hand side, so that's a good start. We've got 4 oxygens times 2 is 8 oxygens, plus 5 times 4 is 20, so that's 28 oxygens on the left. We've got 8 here and 10 twos is here, so that's 28 oxygens on the right. So again, the oxygen is balanced. Let's look at the hydrogens. We've got 16 here. Oops, let me get rid of that. And we've got 8 twos is 16 here, so the hydrogens are balancing up quite nicely. And the last thing to do is the carbons, so 5 twos is 10 here and 10 carbons over there, so the carbons balancing as well, which is great. Last thing to check always is to check the charges balance, so 2 times by 1 over here is minus 2, so that's 2 times by the 1, 16 times 1 is plus 16, and 5 times minus 2 is minus 10. Add all of that together, minus 2 plus 14, that's plus 4 on the left hand side, and on the right hand side we've just got 2 lots of plus 2 is plus 4, so again that all balances up. So whenever dealing with redox reactions, because when playing around with electrons and so on, it's really important that you check balancing all of the time, atoms and charges every single time. Okay, let's have a look in more detail at this reaction then. So the first thing that we could do is assign some oxidation numbers to each of the substances in this reaction. So here we've got manganese and oxygen. Here we've got oxygen would be minus 2 in this. Minus 2 lots of 4 is minus 8, so that's plus 7. If you're not sure where these numbers are coming from, revisit the oxidation states presentation that's already available. You should have already been through that. That's plus 1. This is 4 lots of minus 2, which makes this 2 lots of plus 3. Here we've got plus 2. Here we've got minus 2 and 2 lots of plus 1. Here we've got minus 2 and this one will be plus 4. So if you have a look at the manganese, on the left hand side, the oxidation state of the manganese in MnO4 minus is plus 7. Coming across here, it's reduced down to plus 2. So we could say to ourselves that the Mn has been reduced, so that's reduced. Its oxidation state has gone from plus 7 to plus 2, it's decreased. Whereas the carbon here has gone from plus 3 up to plus 4, so that carbon substance has been oxidized. So this is indeed a redox reaction. Oxygen, though, has gone from minus 2 in both of these examples, stayed at minus 2 in both of those examples, so that's not changed at all. Oops, like so. I'll just reinstate that minus 2 over here. Similarly, the hydrogen, plus 1 here, plus 1 here, that's not changed at all. Whereas both the carbon and the manganese have changed, so it's those substances that are involved in the redox. Okay, this overall reaction is where we should get to eventually, but I'm going to deconstruct this and show you where it comes from. So let's start off with one of those half equations. Now in one of those half equations, I'm going to start with manganese going from the MnO4 minus on the left to the product of that reduction process, which was Mn2 plus on the right hand side. In order to build half equations, the first thing that you need to check is the balancing of the atoms. And the first of those atoms that you check is anything that is not oxygen or hydrogen. So the substance here, which is not oxygen or hydrogen, is manganese, and there is 1 manganese on the left, 1 manganese on the right, so that bit is correct. The second thing that you balance is oxygens, And to balance the oxygen, add water to one side or the other. So in this example, we've got 4 oxygens on the left-hand side and none so far on the right-hand side. So I'm going to add water, and I would need to add 4 lots of water to get the oxygens to balance out. The third thing we balance then is hydrogens. And to balance the hydrogens, we assume acidic conditions. So add H plus to whichever side needs more hydrogens. So in this example, we've got 8 hydrogens now on the left-hand side, 8 hydrogens on the right-hand side, none on the left-hand side. So I'm going to go plus 8H plus on the left-hand side to make that work. And the second thing that you need to balance then is charges. And we're going to add electrons to whichever side, because these are half equations, so we have electrons present somewhere in that equation. So in this example, we've got -1 here, and 8 lots of +1 is currently +7. On this side, +2, so we need to add a total of 5 electrons to the left-hand side to make this work like that. Okay, so we take MnO4-, like so, add 8H plus and 5 electrons. That should make, on the right hand side, Mn2+, I'll just reinstate that 2+ there, and 4 waters. And that now should be a balanced half equation. Always double check, 1 Mn on the left, 1 Mn on the right. 4 oxygens left, 4 oxygens because of 4 waters on the right. 8 hydrogens on the left, 8 hydrogens on the right. -1 plus 8 is +7, plus 5E minus is +2 altogether on the left, and +2 altogether on the right hand side. And notice that we are gaining electrons here, so this is a reduction process because there is gain of electrons. So one half equation will be for the reduction side, the other half equation needs to be therefore for the oxidation side. So let's have a look at C2O4 2- being oxidised to CO2. So first of all, balance the atoms. So we've got 2 carbons on the left. We need to multiply this by 2 on the right to make sure that those are balanced. We've got 4 oxygens on the left and still 4 oxygens on the right now, so that's correct. So the atoms are balanced. Overall charge 2- on the left, so therefore 2E- needed on the right hand side. And this time electrons are released, so this example is the oxidation process. So we've got one half equation for the oxidation and one half equation for the reduction. Putting those all together then, these are the 2 half equations that we just worked out. But when we add all of this together, we need to make sure the electrons cancel. So the electrons must cancel. E- must cancel when we add these things together. Now if we have a look at this example, we've got 5 electrons here and 2 electrons for this one. So if we get into a currency of say 10E- by multiplying all of that lot by 2 and all of this lot by 5, then we should be getting somewhere close to having the correct balanced equation. So let's have a go. I'm just going to add it all together. So 2MnO4- plus 16H plus 10E- plus C2O4 2- all reacts to produce 5C2O4 2- all reacts to produce 2Mn2 plus 8H2O from the top one plus 10 CO2 from the bottom one plus 10E-. The next thing it is important to do is to cancel anything which can be cancelled. So looking just by inspection at this equation, those 10 electrons and those 10 electrons cancel out and nothing else will cancel out. At this stage it's quite common for instance H plus ions or water molecules to cancel out one side or another because of the way that you use those to build the half equations, but in this case that's not relevant. So the final equation becomes 2MnO4- plus 16H plus 5 C2O4, 2 minus, let me just change that one over, C2O4, 2 minus, reacts to produce 2Mn2 plus 8 H2O plus 10 CO2. And then treble check that everything balances. So we've got manganeses. Left we've got 2 here, on the right we've got 2 here, so that works. Oxygens, we've got 2 4s is 8, plus 5 4s is 20, so that's 28. And we've got 8 1s here, plus 10 2s, that's 28, so the oxygen balances out. So all of that lot has balanced. 16 H pluses, and 8 2s is 16 H pluses, that balances. 5 2s is 10 carbons and 10 carbons over here, so all of the atoms are balancing out. So I've checked all of those atoms and they all balance up properly. Final thing to double check is that the charge works. So over on the left hand side we've got 2 times by minus 1 is minus 2, minus 2 plus 16 is plus 14, minus 2 times 5 is minus 10, so that's plus 4 altogether on the left hand side, and 2 lots of plus 2 is plus 4 all over on the right hand side. So that now is a fully balanced redox equation. Okay, now that we've been through the steps and stages for balancing and writing these redox equations, go and have a look at some of the examples that you've been set to do, and dip back into this video if you need to do so, please.